Hello, welcome to section 6.2. What we're going to do in this video is solve systems of equations using a method called linear combinations, also called elimination. If you're in the math land like I am, the slang is called elimination. If you're cool enough, you can call it elimination like me. Okay, enough with that. Now, what we're going to do is work through a couple problems. Elimination is an algebraic way of solving something. We've done graphing, we've done substitution, now there's elimination. So we'll do a couple story problems along with these three examples. We'll see what it looks like if you have no solution or infinitely many solutions, and then we'll take a look at what graphing, we'll take a look at the story problems for these, and we'll do one story problem with linear combinations, and then I'll show you what one with substitution will look like, so that whenever you write your equations for a system, you'll be able to pick which method you'll prefer between the two. So I'll start off with an easier example just to kind of introduce how elimination works. What you're trying to do is add two equations going straight down. You want to be able to add your x's, add your y's, add your constant terms, so you have two equations in standard form. That's when we're going to use elimination, is if your equations are already in standard form. We wouldn't want to use substitution, we would use elimination. And what you want is for when you add going straight down, you want one of your variables to eliminate. So I'll show you what that's going to look like here. If I have 3x and I add 2x, I get 5x. Now here's where the elimination comes in. You have a positive 5y and you're adding a negative 5y, which means there's no y's left over. So it eliminates, and you can add your constants together. 8 plus 22 is 30. And what you end up with is an equation, 5x equals 30, which you can simply solve for x. Once you have part of your coordinate for your answer, because remember our answer is going to be an ordered pair, it's going to be a coordinate, what you can do is substitute this right back into either one of these two equations and figure out what the y coordinate is. So we'll talk about other problems or other equations where you're going to have to do stuff with the equations first before they'll eliminate. But let me finish this example. What I'm going to do is take 6 and substitute it back into either of these equations. I'll do it back into the top equation. Oops. And again, we're substituting it in for x. So x equals 6. So I have 3 times 6 plus 5y equals 8. So 18 plus 5y equals 8. Subtract 18 on both sides. So we're trying to get that y value. 5y equals negative 10. So when you divide both of your sides by 5, I'm kind of cruising through the algebra here. So y ends up being negative 2. So our final answer is the point 6, negative 2. So it seems like in that example it would be a lot easier to use than substitution, but that's only because our variables, our y is eliminated right away. So let's talk briefly about why that happened. So if you remember, that number in front of a variable is called a coefficient. So well, that is just horrible. Wait, yeah, coefficient. Whatever, that's just awful spelling. So the coefficient is the number in front of the variable, and notice that I have a positive 5 as a coefficient on one, and then I have a negative 5. So what you are looking for is opposite coefficients for a variable. You want one positive and one negative. You want it to be the same number so that these will cross out, they'll eliminate. When you add a number and its opposite, you get 0, which means it's gone. So that's what we're going to look for in the next one, but notice we don't have opposite coefficients here. I have a 4 and I have a 2. I have a negative 1 and a positive 2, and then we have our constants. So what we're going to need to do is find some way to eliminate a variable here. So I'm going to pose the question, what would eliminate with a positive 2y? And hopefully you're thinking in your head, a negative 2y. But that's the problem. Our top equation doesn't have a negative 2y, it just has a negative y. So we're going to need to multiply this whole equation by some number so that I can eliminate my y's. And we could have picked x's. You can always eliminate x's or y's. I found the y to be easier in this case because your signs are already the opposites of each other. You already have one negative and one positive. So watch what I'm going to do. I'm going to multiply and distribute this entire top equation by positive 2, and watch what happens. 2 times 4x is 8x. 2 times negative y is negative 2y. And don't forget, 2 times 2 is 4. So don't forget that last constant term. I see that mistake a lot. What I'm going to do is take the bottom equation and just write it directly underneath. I have 2x plus 2y equals 26. So take a look. We wanted one of our variables to eliminate. I'm going to add these two equations going straight down. 8x plus 2x is 10x. And notice what happens here. I have a negative 2y and a positive 2y. It's going to eliminate. So I really only end up with the 10x, and I'm going to have that equal to 30. So when you divide both sides by 10, x ends up being 3. So I have part of my answer. I have the x part of the coordinate. Now I need to find the y part of the coordinate. So it doesn't matter which one of these two equations you substitute it back into. I'm going to substitute it into the bottom equation. So again, we're putting 3 in for x. So 2 times 3 plus 2y equals 26. And now we're just solving for what that y coordinate is. So 6 plus 2y equals 26. I'm going to subtract 6 on both sides. I end up with, and I'll do it over here, 2y equals 26 minus 6, which is 20. When you divide both sides by 2, you're going to end up with your y coordinate is going to be 10. So our final answer is the point 310. So just to recap again, the reason we multiplied the entire top equation by 2 was to eliminate our y variable. So I'm going to take the same system and I'm going to look at the x's. What would it take to eliminate the x's? If we had a positive 4x on top, what would we need on the bottom to eliminate a positive 4x? We would need the bottom to be a negative 4x. So if you were going to eliminate your x's, what you could have done is actually multiply the whole bottom equation by negative 2 all the way across, and what would end up happening is you would have the 4x on top and you would have a negative 4x underneath it. If your x is eliminated, you would actually be solving for y first and then substituting that in to find what x is. So you can do that problem either way. It doesn't matter which variable you decide to pick. The reason I chose to use y is because I already had opposite signs for my coefficients. Here's another example. This might be the one with the no solution. I already forgot. Let's take a look here. I have a negative 4x on top. I have a positive x on the bottom. I have a positive 9 here and a negative 3. So I'm going to need to do some work first to figure out which variable to eliminate. I'm going to pick the y's here, even though, again, I could have picked x's. It doesn't matter. But if I want to eliminate my y, what's going to cancel or eliminate with a positive 9y? I'm going to need the bottom to be a negative 9y. So what would I need to multiply this by to get negative 9? And that would end up being 3. So what I'm going to do is bring the top equation over. Negative 4x plus 9y equals 9. And my bottom equation, I'm going to multiply the whole thing by 3. And I end up with 3x minus 9y. And that's going to equal negative 18. Actually, this is not one of those no solution problems. I don't know what I'm thinking. What I'm going to do is add going straight down. I have negative x. That's going to eliminate, equals negative 9. If you divide both sides by negative 1, my x is actually going to end up being positive 9 then. So this is just another example. I'm going to have to go through a couple more then that I'll just make up. So what I'm going to do is substitute this back in. It doesn't matter which equation. I'm going to substitute it into the bottom one. So 9 minus 3y equals negative 6. Subtract 9 on both sides. I'm going to do the work over here. Negative 3y equals negative 15. So that means if I divide by negative 3 on both sides, y is going to end up being positive 5. So my final answer is the 0.95. So what I'm going to do is pause real quick. I need to come up with 2 more examples we're going to do after this. I'm going to give you one challenging example, and then I'm going to find one for a no solution. Okay, so here's an example. This is going to be more of a challenging one. Notice that in this problem, I'll give you a sec to kind of take a look at it. If you wanted to cancel or eliminate anything for your x's, there's nothing that you can multiply 2 by, like a whole number that's going to give you 5. And there's no whole number that you're going to multiply 2 by over here that would cancel with something with a 3. What that means is that you would actually need to multiply both of your equations. So I'm going to do that, and I'll show you how. I'm going to eliminate my x's. And I'm going to do that by multiplying by a negative for one of them and a positive for the other, and that's going to give me opposite coefficients. But let me give you or show you how this is going to work. If I look at my coefficient to this x is 2 and my bottom one's 5. So my least common multiple of 2 and 5 is if I just take 2 times 5, which is 10. So what I'm going to do is take this top equation and I'm going to multiply it by -5. And I'm going to take the bottom equation and I'm going to multiply it by +2. So what I'm really doing, if you take a look at my cursor, is these are going to be the same number and so will these, except one of them needed to be an opposite. So I'm going to multiply going straight across. I have -5 times 2x, which is -10x. I have -5 times 3y, which is -15y. And I have -5 times 8, which is -40. On the bottom, I'm going to end up with 2 times 5x, which is 10x. I have 2 times 2y, which is 4y. And I have 2 times 18, which is 36. So what ends up happening then is I found a way to multiply both of my equations so that when I add these x's together, they will cancel out. So I have a +10x and a -10x. It eliminates. -15y plus 4y is -11y. And then -40 plus 36 is -4. So if I wanted to solve this, I could divide both sides by -11. And I would end up with y equals -4 divided by -11 is +4/11. So it's an ugly number, which is okay. Not every one of these answers is going to come out being pretty. So what I'm going to do to figure out what my x-coordinate is substitute 4/11 in for, again, either of these original equations. So I'll pick the top one. I'm going to do 2 times x plus 3 times my 4/11 and set that equal to 8. So I have 2x plus, this is going to come out to 3 times 4/11 is 12/11, set it equal to 8. What I'm going to do is subtract the 12/11 on both sides. So you're getting a little work in of subtracting some fractions. You can go to your calculator on this if you'd like. I'm going to take 8 minus 12/11, and I end up with 76/11. And then your last step is just to divide by 2. And I'm going to end up with 38/11. So I got a really ugly answer. My x-coordinate is 38/11, and my y-coordinate is 4/11. But that's okay. This is just a really extreme example. It's a very, very difficult problem in a sense that you had to multiply both of your equations so that one of your variables would eliminate, and we also had to deal with the fraction. So don't just run away from the fractions and the decimals. A lot of real-world applications are going to have decimals and really not nice numbers. So this is just an example of one. Here's an example. I just want to make this one real quick. Take a look. If I add going straight down here, a +3x and a -3x is going to eliminate, and that ends up crossing out. And a -y and a +y is also going to eliminate. So on the left side, you really have nothing left. You have 0. 10 plus -8 is +2. So this looks like the ones in the last video that I did when we had substitution problems where your variables dropped out and you ended up with something that was not true. That would come out to a no solution. If I ended up with 0 equals 0 here, then I would have an infinitely many solutions. But since 0 does not equal 2, that is a no solution example. So that's what would happen if your variables both eliminate. Now I'll go on to a couple story problems. The high school marching band is selling fruit baskets as a fundraiser. They sell a large basket containing 10 apples, 15 oranges. That's $20. They sell a small basket, which is 5 apples and 6 oranges, and that's going to be $8.50. So how much are they charging for each apple and each orange? So the first step here is to define my variables. I'm going to let A be the cost of apples. Actually, you know what? I'm going to use X and Y, because if I use A and O, my O's are going to look like zeros. So I'm going to let X be the price per apple, and I'm going to let Y be the price per orange. And again, that's a very important step just to define the variables. You can usually grab that information from this last sentence here where it says how much are they charging for each apple and orange. So that means that the cost is the variable, not the quantity here. So now I'm going to write 2 equations. These are in standard form. Their basket is, the first one contains 10 apples, so 10 times whatever the cost is, for apple plus 15 times the cost of an orange, and they're selling that for $20. And then the small basket has 5 of the apples and 6 of the oranges, and that one is $8.50, so 8.5. So this is a really good example for elimination. Take a look at these two. Notice that there's nothing on a whole number that I can multiply 6 by to get to 15. So I'm going to have to eliminate my x's here. What am I going to multiply, or I should say, what is going to eliminate with a positive 10x? And that would be a negative 10x. So what would I need to multiply this bottom equation by to eliminate? And that would be a negative 2. So what I'm going to do is rewrite my top equation, 10x plus 15y equals 20, and the bottom equation, negative 2, well, multiply all 3 of these things. Negative 2 times 5x is negative 10x. Negative 2 times 6y is negative 12y. And then I have negative 2 times 8.5, which is negative 17. So what I'm going to do is add going straight down. What I wanted to happen was for my x's to eliminate, and they did. I have a 15y and a negative 12y. When you add those together, you get 3y. And 20 minus the 17 would be 3. Divide both sides by 3. And what that means is the cost for one orange is $1. Seems like an expensive orange, but I think that's pretty legit. So the cost of an orange is $1. What I can do is take this $1 and substitute it into either one of these equations. I'll substitute it into the top. So I'm going to have 10x. So 10x plus 15 times 1 equals 20. So 10x plus 15 equals 20. Subtract 15 on both sides. I'll give myself a little more room to work here. So 10x equals 20 minus 15, which is 5. And at the very end, let's divide both sides by 10. And 5 divided by 10 is, of course, half. So I'm going to write it as 0.5. So as a coordinate, I would express this as 0.5 and 1. But since it's a story problem, I want to give this meaning. So the cost of each orange is $1. And each apple is 50 cents. So since we have story problems a lot, what we want to do is get in the habit of answering whatever the question is asking for in a complete sentence. Since it says how much are they charging for each apple and orange, I answered what I have in the purple here. I gave the cost of each of these. And again, what we did was we set up 2 equations that were in standard form, and I used the elimination method to solve it. I'm going to do one more example of a story problem, but this one we're going to use substitution to solve instead. Okay, Rachel needs to print some of her digital photos. She's trying to choose between basically 2 companies. One place is charging a base fee of $5 plus 20 cents per photo. Another place is charging a higher fee, but it's cheaper for photos. So we need to determine basically how many pictures both stores would charge the same amount for. And that means if she goes past that amount, one place will be a lot cheaper than the other. If she doesn't produce that many, one place would be more expensive maybe. So what I'm going to do is write both my equations, but before that I should probably define my variables. So it says determine which store she should choose depending on the number of photos she decides to print. So I'm going to say that P is going to be the number of photos. And what's going to depend on that? So if she produces more photos, that means the cost will be more for both. So I'm going to say the cost is going to be my other variable. When I write these equations, they're actually going to be in slope-intercept form, since they're telling me it's going to be something per photo here. The number of photos is what she controls, and the cost is going to depend on that. So one place is charging 20 cents a photo, the other is charging 10. So I'm going to write my equations. Cost equals one place is charging 20 cents, so 0.2 times the number of photos plus the $5 fee. And the other place is charging 10 cents a photo, so 0.1 P plus a fee of $7. So I have 2 equations that are in slope-intercept form. Instead of y equals mx plus b, I have c equals something times p plus the b. So when you have two equations in slope-intercept form, I'm going to use substitution to solve these. I'm going to take this expression here and substitute it in for c, since it's what c equals. And what I'm actually going to do then is basically set both of these expressions equal to each other. 0.1p plus 7 equals 0.2p plus 5. And then we need to find a way to solve this. So I'm going to subtract 0.1p on both sides. And I'm going to end up, scroll down, I'm going to end up with 7 equals 0.1p plus 5. And now what I'm going to do is subtract 5 on both sides. My 5s look like S's, I apologize. 7 minus 5 is 2. So I have 2 equals 0.1 times p. So what I need to do is take 2 divided by 0.1, and that's going to tell me for how many photos she decides to print. Both places will be the same price. And p ends up being 20. So if she does 20 photos, what that means is the cost for each of these places will be the same. So let's figure out what that cost is, because I want to figure out what my solution is to this. So c equals 0.2, I'll take the top equation, c equals 0.2p plus 5. So what I'm going to do is substitute 20 in for p, and that's going to tell me how much it'll cost. Again, it doesn't matter which place you choose because they're both going to represent the same cost. So I'm going to take 0.2 times 20, which is 4, plus the base fee of $5. So what that means is that if she prints 20 photos, it's going to cost her $9 at both places. If I were to take 0.1 and multiply by 20, I would end up with 2, and 2 plus 7 would also mean that this other place would be charging $9 per photo. So if she prints more than 20 photos, I want to pick the place that has a cheaper rate. So if she's printing more than 20, she's going to want to go with this bottom company because they're charging 10 cents instead of 20 cents. Even though their fee is larger, she is printing more than 20 photos, which was where both places charge the same. So again, the quick recap, we did a lot of elimination examples. I did 5 examples. The first 3, you were multiplying one equation. Or actually in the first example, we didn't even have to multiply either of the equations. In our 4th example, we had to multiply both equations. I showed you what it looked like if we had a no solution. And then we went through a story problem using elimination and a story problem using substitution.